Okay, so Azure Service Bus. So this talk basically is a sort of sequel to an introduction talk that I did a while back. There's a link to the introduction there, and I'll send some of these links around later on. So that's me. I wrote a book some time ago, which pretty much instantly got taken out of well, not taken out, but superseded when .NET 5 came out. But that's still in print as far as I'm aware. So if you want to find out about .NET Core 3, then you can do. I'm a Microsoft MVP. I also run a meetup of my own called MiniHack. We encourage people to come along and find pointless solutions to neat solutions to pointless problems. It's just basically a bit of fun, a 2-hour hackathon. Cool. Okay. So there's some demos in this talk. The problem with demos is that they tend to go wrong quite a lot, and it's actually a good time for me to introduce something that I've tried a couple of times. So we'll see how it works with this. I've got a direct poll set up, and I'll post, if I can do, in the chat. If I can find the chat. Video. Why? Right. Okay. I'll tell you what I'll do, Mohammed. If I can. Oh, actually, it's all right.
I sent something on the chat, so maybe you'll be able to see it.
I am not. Interesting. Tell you what I'll do. I've got you on LinkedIn, so if I can just put it on there for you, and if you could post it on my behalf, seeing as how I'm in some strange sort of logged in and logged out state with Zoom, which is very bizarre.
I'll post it now.
Jump back here. I've not sent it yet.
When you send it.
It's this one. There we go. Okay, cool. And then
done.
Run this again. Okay. So if this works how I think it will work, people should be able to vote on this pointless thing here. Excellent. Okay. And then I can advance that to the next question, which is a bit less pointless. So demos are dangerous. They go wrong, and I'd like everyone to just pretend that everything worked, and we'll move on and never speak of it again. So the next the next question is that people need to solemnly swear to never speak of any failures during the talk. Cool, excellent. That sounds positive. Okay, I'm going to assume that people are familiar with the basic principles of a message broker. I'm going to assume that people know what Azure Service Bus is, and that they understand at least what a queue and a topic is. If anybody, I think I've got another question here to see how close we are to that. So the question is just, have you used Service Bus before? Okay. That's a cross section then. Okay, excellent. I'm guessing you're the one who voted. You've heard of it but never used it, Sean, right? Cool. Okay, so onto service bus libraries. So essentially, this is, in my opinion, the most confusing thing about service bus, and it has thrown me a lot, and it still throws me now. So I got this. It might actually been off one of Sean's blog posts. I'm not sure, but back in 2011, Microsoft released a Windows Azure Service Bus SDK. That's .NET Framework. It's closed source, as far as I'm aware, and it's generally speaking not used anymore. So you should not use that in any new projects. In 2017, they released Microsoft.Azure Service Bus. That is definitely still used. I can attest to that because I know several places that still use it. It's open source, I believe, and it uses .NET Core. And then in 2020, Microsoft released a new SDK, Azure.Messaging.Service Bus, which is the new and shiny SDK. It does some things that that the other one. It does some things that this one doesn't do, which I'll get into later on. But it's that's generally speaking, and it also doesn't do some things that this one does do. And again, we'll talk about that later in terms of what it does and what it doesn't do and why that's the case. Cool. Okay, so the cool features that I wanted to cover today: dead letter processing. So this is the in brief the feature where you can effectively a message that's a problem message, stop processing it or move on to the next message. Transactions, which if you've ever used a database, you'll know what a transaction is. It's the ability to kind of encompass more than one. Don't want to use the word transaction again. More than one events into a sort of umbrella transaction, so that if one fails, all fail. Scheduling deferred messages. So this is the thing where basically you can send a message in the future, if you like, and a deferred message is you can receive a message in the future. Sessions, which are basically a neat way of kind of doing a request response pattern in Service Bus. Management, which again is an interesting one because I think that's one of the ones that the new library will let you do, whereas the 2017 one will not. Auto forwarding and auto delete. Again, the ability to have messages going from one queue or topic to another queue based on a rule, and auto delete is the ability to have a queue or a topic kind of disappear if it's not used. Prefetching and batching are kind of performance based events, and I'm going to talk a little bit as well about Azure function binding and identity based connections, which are both quite interesting features. Cool. Okay, so we'll start off with dead letter queues and transactions. So a dead letter queue, for anybody who's not aware, a queue basically you're processing your messages, they're all being processed, and then at some point one of them, something goes wrong with it and processing stops, and then what happens is all of the messages that are behind it can't be processed because that one message would need to be processed. So the idea behind a dead letter queue is the exact same thing, but then when you get that message, that comes along and you can't process it and everything starts to queue up behind it, you just bung it into a separate box and then you can carry on with your processing. Incidentally, if anybody wants any PowerPoint consultation, I'm available. Cool. Okay, so we'll the message. Why does a message get put into the dead letter queue? You can explicitly put a message into the dead letter queue, which we'll cover. If it tries too many times to deliver it again, we'll talk about what that means in a minute. If the message expires, if the session, when we get onto sessions, you'll see that you kind of have to flag something as a session or not a session queue. If you get them mixed up, then messages will start ending up in a dead letter queue. And if you have a forward that kind of goes around more than 4 times. So in summary, it's anything that the system thinks is going to cause you a problem or clog something up, it'll put in the dead letter queue. Transactions. Okay, so a transaction, we said this before, it encompasses more than one or more events. So the summary is everything works or everything doesn't. And there's a reason that I've covered the dead letter queue and transactions together, which is this demo. Okay, so this is the first demo. You'll notice all these demos are console apps, and that's because I couldn't find a better UI. People going about React and Vue and all that kind of thing. I think that the console app is by far the best, and I don't know why anybody would bother with a Spa, to be honest, when you've got this front end available to you. Okay, so what I'm going to do here, I'm going to send a message, and I'm going to send it to a queue, and if I can find it. So this is the Service Bus Explorer. You can get it. You can download the source code and just run it. You can use Chocolatey to install it, which is what I did. It's written, I believe, in WinForms, and it's a bit clunky, but it's still, as far as I can see, the best way of looking at messages. So you notice there's a message gone into the dead letter queue, and if I have a look at what that message is, I'll see that it's a bad message. So what I'm going to do now is I'm going to abandon that message. So basically, I'll show that later on, but we're basically going to try and pick that message up and then not process it, abandon it. And you'll notice that it's now got a delivery count of 1. If I continue to abandon this message, what's happened is delivery count is going up and up and up. And eventually it will reach 10. At which point, if we go back to the service bus, we'll see that it's been dead lettered. Oh, didn't mean to do that. Get the Azure Studio back and this back. Okay, so the next thing is I'm going to send a new message, and then I'm going to explicitly abandon that. I'll show the code for this again in a minute. So here I'm going to dead letter the message explicitly, and then I can have a look in the Service Bus Explorer, and I can see again I've now got 2 messages in the dead letter queue. There's 2 other things that I can do here. The first one is I can view the dead lettered message, which is quite interesting. It goes to the dead letter queue is basically a kind of special sub queue, if you like, inside the main queue. And the other thing I can do is I can resubmit that message. Now this is a bit of a cheat, and I'll sort of go over why it's a bit of a cheat in a minute, but to all intents and purposes, this message has been resubmitted. Cool. Okay, so let's have a look at how that's working. Okay, so the first thing I want to point out, got a dead letter path here that basically sort of, don't want to use the word magic string, but magic string, it tells you where the dead, like the sub queue that the dead letter queue is in. And as we're reading the dead letter queue here, when we're reading it, then you'll see it goes to that sub queue. The way I've done that, I've created this function called format dead letter path. I've done that because previously in the and I keep on forgetting the format of the namespaces, but previously in the 2017 SDK, there was a function provided that did this for you, and that seems to have gone. So I've just written my own to not have to keep on typing in that same string interpolation. If we go back to the first method that I sent, the send message. So this is basically the way that the new sort of SDK works. You create yourself a service bus client, and that allows you to then create a kind of the thing that you want. So you can create a message sender, or you can see that there's also a processor, a receiver, a session processor, and we'll go into all of these separately. It's also worth bearing in mind that I've got a user here, so that's scope to this function. I'll come back to it when we talk about processes later on, but there is a sort of schoolboy mistake you can make where you do this and then you create a processor and then it starts processing the message and goes, what's happened to your service bus client? So that creates the sender, and then basically you just call send message async to create a message, which is kind of service bus 101, I suppose. And again, with the reading a message, all I'm really doing here is I'm doing exactly the same thing but creating a receiver and receiving message. The only interesting part here that relates to dead letter is that if I'm dead lettering the message, I call this abandon message async. So there's effectively two modes, two things you can do with a message when you've picked it up. You can abandon it or you can complete it. If you abandon it, then what happens is the delivery count increases and eventually it'll get dead lettered. And then, so if we go back to the part where I explicitly dead lettered the message. So what's happening here? I've exactly the same sort of Chrome, if you like, as the first two methods. But then what I'm doing is I'm saying, okay, now I want to explicitly dead letter that message and just send it to the dead letter queue directly. And then finally the resubmit. Now let's cover the reading the dead letter message. I think we kind of did, but just to talk about this format dead letter path. That's effectively exactly the same thing. So it'll just let you read off that queue, just given that sort of special path, if you like. And then finally the resubmit. Now the resubmit is the cheat that I was kind of talking about before. So all this does is it reads a message from the dead letter queue. Now, previously, what you could do in the previous SDK is you could call a clone message method, and you could basically take the method and duplicate it, and then you could kind of send that on. What this now allows you to do, and it's actually much better, is when you create a service bus message, you can pass it the existing message. But the good thing here is it doesn't bring across the properties that kind of indicate this is a dead lettered message. And so there's none of that you have to mess about with. You can just resubmit it. The other thing that's worth bearing in mind, because we were talking about transactions, is that I've got a transaction here. And the reason I've got a transaction is that if I take that message and it doesn't resubmit it, then it will never complete that initial message, which means that the message won't be lost, they won't pick it up, and kind of it'll go away or whatever. And then I complete the scope. Cool. Okay, so that's dead lettered messages. Mohammed, I can't see the chat, so if anybody's asking any questions, I now can see the chat.
Don't worry. If there is anything, I'll let you know.
Cool. Okay, that's all right. I can see it now. I don't know what's going on there. Why that suddenly stopped? Cool. Okay, so question is, so what do you do with a dead lettered message once it's dead lettered? And the answer is obviously it depends. Because like can't give proper answers to these questions, otherwise we won't get paid anymore. It depends why it's in the queue. So it could be caused by a software fault, transient failure, or some data is corrupted. You could be trying to communicate with a third party that for whatever reason you can't. So there's no one answer, but you should probably at least log it and probably notify somebody if you've got a dead letter. But then I suppose it depends what you're using them for. Okay, so scheduled and deferred messages. So scheduled messages basically allow you to send a message in the future. So I've put some examples of why you might want to use it. If you wanted to send an email later on that day, and that was running off a service bus message, then maybe that would be a use case. The other that I've used quite a bit is if you write in some kind of exponential back off on a dead letter to try and work out if it is a transient fault, this is a good way of doing it. So you basically pick up the dead letter message and you just try it again. And then if it doesn't work, you try it again in 10 minutes or something. So let's see if we can work out what's happening. Scheduled message delivery. Can't remember what changed now. Right, cool. Okay. So this one's an interesting one because it always worries me, because what I'll do is I'll say I want to receive the messages here, and then what I'll do is I'll send the messages, and nothing happens for 10 seconds, and so I now have to talk for 10 seconds to make it sound like this is planned, and then in 10 seconds this is either going to turn up or I look like an idiot. Okay, so that waited 10 seconds to arrive, and the reason that it waited 10 seconds to arrive is because it was scheduled to arrive in 10 seconds. I'll start with the read messages because this creates this process that I was talking about earlier, and this was basically the first time that I realized that if you scope the service bus client using a using statement, and when you actually come to process the message, it craps out. Essentially all that's doing is it's just setting up an event-driven sort of message receiver. The scheduled message, again, there's nothing kind of complicated about that. It just does exactly what we did before. This time it just basically does a scheduled message async. You'll see there as well, it returns a sequence number, and if you want to cancel that, you can do so, but you need that sequence number. So if you're kind of using it in production, it's usually a good idea to store that a sequence number somewhere so you can cancel it later on. Okay, so custom properties. Now this is an interesting one. Again, it's something that's changed a little bit. So this is quite a neat little feature because it allows you to store sort of key value pairs against your message. So previously this was user and system properties. and they've changed it to application properties because the system properties seem to have been promoted into a sort of first-class citizen, if you like. And so, and this, again, I've come back to this little timeline thing. So in this timeline, it was sort of user and system properties, and then when we get to here, it's application properties. Oh, hang on. Have I skipped? Oh no. Okay. Deferred messages. So deferred messages, another almost like the opposite of scheduled messages. So this is you're receiving a message, but you don't want to receive it at the time that the message arrives. So you can basically say, I do want this message, I don't want it now. So usually it's if you receive the message. So if, for example, you've got some kind of microservice architecture or whatever, and you're receiving a message, do some processing, but you know that the system isn't ready for that processing. So put eventual consistency there. Okay, so the deferred messages. Okay. So the deferred message demo, basically, this kind of encompasses the properties as well. So what I'm going to do here, I'm going to send two messages. I'm going to send one that's flagged as ready and one that's flagged as not ready, and I'll talk about how I flag them as ready and not ready. So there's the ready one. There's a not ready one. Let's have a look in the Service Bus Explorer, and we'll see how they're flagged as ready and not ready. So this is the message queue that they're sending to deferral. And there you can see this one is we're ready for this message. This one is I'm not ready for this message. And here you've got these custom properties. So basically, this is something that I've just set up as a sort of custom property, and I said this isn't ready. This is ready. But that's me. I could have called it aardvark. The other thing that's worth pointing out here is the state of the message. So they both have a state of active. So what I'm now going to do is I'm going to receive them. So receive the ready message, and then if we have a look here, we'll see that one of the messages disappeared. That's a ready message that's gone. Nothing. Okay. I don't know whether I should be admitting these people because I don't know who they are. This is still active. And if I now receive the message, the not ready message, so I'm gonna basically receive a message again. What I'll see now, if I have a look at these messages, is that the message hasn't been received, but the state has now changed. So it's tried to receive this, but it's deferred it. And that message is in a very strange state, in that it can never ever be received now until it's specifically or explicitly received by a special method. So what I'll do now is I'll receive that deferred message and show it being received. So that's receive the deferred message, and then if I refresh again, it's gone. So let's have a look at the clean message. I'll talk about in a minute. That's just for my sanity, that method. So we're here, aren't we? Okay, so the send message is nothing really to sort of write home about, except for this line, which is that effectively I've added a custom property. So in the message, there's an array or a collection of key value pairs, effectively, and I've just said is ready, and then I've passed it a flag. So that's kind of how you set up the custom properties. The receive, the receive and defer. So this basically is the method that allows you to receive a message and then defer it later on. So what I'm doing is I'm as we did before, just receiving the sort of bog standard message, but then I'm reading that custom property that we were talking about. So I'm saying if it contains the is ready key and it's not ready, then what I'm going to do, I'm going to store the sequence number and then I'm going to defer it. When I then try and receive that deferred message, I can only do it using this this method of receive deferred message, and I have to pass it a sequence number. And if you get to the state in between the two and you lose the sequence number, then the only way that I've come across that you can actually get rid of it is basically to find out what because this Service Bus Explorer will kind of have a look at, tell you what it is. So you can then call that, and I've just got a method here that allows me to tidy it up, because otherwise it gets stuck. Cool. Okay. So it's deferred messages. The next section is on sessions. So sessions are really interesting. You can use Service Bus to implement a request response pattern. So this is the situation where you basically want to do a real-time call or near real-time call out to say a second process or whatever. You want to use Service Bus, but you don't want to kind of be completely offline. So you essentially want to send the message and then get a response. So typically you can use a sort of pattern like a correlation ID, where you give it an ID, you send the message out with an ID, and the response comes with the same ID. And while you're waiting for that response to come back, you just block. Sessions kind of allow you to do that. It's sort of built into the to Microsoft Service Bus, and I think the Azure Service Bus is the only, or I've never come across this kind of functionality that you didn't sort of have to roll your own in other message brokers. So sessions, they're guaranteed to be FIFO, whereas normal Service Bus messages are not. The queues that you set up must be session aware. This was what I was talking about before when we were talking about the Service Bus message. Could be dead lettered if it kind of got mixed up. So if you try and post the session message to a non-session queue, it will dead letter. And it's also not available on the basic tier, which means potentially costs a little bit more. And the way it works is this: so we've got a series of messages, and you just allocate them a session, and this just basically creates two virtual queues. So one for session one for session two. And then, yeah, just sort of how you would create that session, the queue. Sorry. Cool. Okay, so demo and session. So, so this one. Okay, so again, I'm going to send some messages to the queue, or a message, and we're going to have a look at it in Service Bus Explorer. That's in queue session demo. So there's a couple of messages there. If we have a look at them, we'll see that they're slightly different. So there's one message and there's one what I've called noise message. So obviously the idea is that we receive the message, but we don't receive the noise message because we're not interested in it. So what I'm going to do here is I'm going to receive messages only for session 1. And that should, receive, and then it's left the noise message there. So we're just dealing on one session. So what I'm going to do now is I'm going to launch a second instance of it. Okay, go back to the first one. Okay, and then here on the first one, what I'm going to do is I'm going to send a message and await reply. And then on the second instance, I'm going to receive that message. And then if you jump back to the poll, you should see that the poll has advanced to a bit of a quiz. So if anybody knows what song and artist that line is from, feel free to vote. It looks like one person at least knows.
Paul, I have a question.
Yep.
So what do you think is a good use cases to utilize the sessions? Because I'm trying to wrap my head around it, about the good use cases for it.
So the advantage, I mean, basically it's where you would typically use an API, you would use this instead. And the advantage is that you don't couple yourself to the API service, if you like. There's obviously downsides to it in that you're, in a sense, coupling yourself to the service bus and you're decreasing your speed a little bit. But that's essentially the use case, that you're trying to communicate between two services, but you don't want to establish a direct communication path, so you go via a third party essentially.
Okay.
I've seen it done where that was an absolute standard and nobody was allowed to call an API, so everything went through Service Bus. It does give you an advantage where there's not really a server and a client, if you like, so you don't have to have one thing that accepts that and one thing that doesn't. You can both accept it or not.
Yeah. Because I have never seen this in a production environment before.
Only seen it once, and like I say, I don't want to say it was overcomplicated, but I can certainly envisage places where it'd be very useful. Because architecturally it does kind of loosen you up a little bit. But there's a bit of a trade-off that you make there.
Yeah. Thanks.
Cool. Okay, so I think what happened there was I think it crashed because I was waiting too long. So I'm going to run that again. Twice. And okay, so we're going to send that again, and here we'll receive it. And then in the second instance, what we'll do is we'll reply to that message. And you see there when it's replied with the title and the artist, and it's done so in that kind of communication. How many people got that? Oh, 2 people got that. So we've got 2 Pink Floyd fans in there attending. Cool. Okay, so that so essentially this message where it sends the message with a session, all that's happening there is it basically when it creates the when it creates a service bus, it creates a sender as before. This time, when it creates a message, it adds a session ID to the message, and then you can just send that message. Obviously, there's nothing to stop you. You know, if I didn't pass this through, that then you end up with that business where you mix in sessions and non-sessions. The read message again is nothing hugely different. Same sort of initial thing, but this time instead of receiving the message directly, you basically have to create a sort of session reader, if you like, and then you can use that to receive the messages and complete them. And then the way that this sort of little dialogue works is I've basically sent the message initially on one session, and then I've read the message on a second session. So we're effectively having that communication over 2 sessions, so that it can kind of go back and forth. Cool. Okay. So that's sessions. Service bus management. Okay, so this is an interesting one because I think this is, I wouldn't say it's unique, but I don't think that exists in the 2017 SDK, or if it does, then I've not come up with a good way of using it. So this allows you to basically, it's kind of it's not exactly infrastructure as code, but it's a sort of poor man's infrastructure as code, if you like. So it allows you to set up things like queues and topics in code. So you might, you know, if you were using infrastructure as code, you might want to set up your service bus as an infrastructure as code, but then have the code create the queues and topics or whatever itself, so that you know that it exists before you write to it. I'm going to talk about auto forwarding and auto delete. So auto delete basically allows you to have the service bus itself delete a queue or a topic or whatever if you aren't using it. So an example would be, you know, we send emails for an event, for example. If the event expires, then you might just want to trash that. So you might want to set its lifetime to a couple of hours or whatever. And the auto forwarding, this allows you to decouple the receive queue from send queue. So everyone could send a message, for example, to a single queue, and it can be broadcast to different topics. So the use case that I've kind of come up with that, if you're re-architecting a queue structure or whatever, you can kind of use it for that reason. If you want a centralized dead letter queue, then you can do that. But it's worth bearing in mind that after 4 forwards, then it will dead letter, just to prevent you kind of dimming the lights in Seattle while it bounces messages from one place to another. Okay, so this is kind of what I mean by the re-architecting. So imagine that you had a queue, and this is a busy production environment, and you decide that you want to change the queue that you're sending messages to. So you could create a new queue, and then just flag the original queue as auto delete and idle. Your messages start going to the new queue, and as the old one isn't used, it'll just trash it after a period of time. Okay, so if we run up again on this, so give it that, collapse all this so I can see what I'm doing. Service bus management. Okay, so what we're going to do here, I'm just going to delete these queues, and then I'll show the Service Bus Explorer. So you might notice that something kind of went away then. I'll now run create queues, and you'll be able to see better what kind of went away. So it's created these two, effectively these two queues here, auto forward queue and a source queue. You'll also notice that this has got forward to in it. So the source queue has got basically forwards to the destination. So these two queues have been created by encode, and this one has an auto forward on. Okay, so if I now I can show the connection details. So this is just a feature of kind of service bus management. You can see the connection details. Now what I'm going to do, I'm going to send a message to the source queue, and what we'll notice, although it's kind of a bit of an anticlimax, this is that it doesn't send to the source queue, or it does send to the source queue, and then the source queue sends to the destination queue. So the destination queue is actually what receives our message after it's been received. Cool. Okay. So we've got the next question in our little quiz now. So I'm just going to advance on to the next song. So anybody know the title of that song? Nope. Nobody does. Oh, one person does. So that was Ace of Spades by Motorhead, for anybody who doesn't know. Clicked off that again.
Quick question, Paul, on the forwarding. Can it be conditional based on certain custom parameters that we have set before? We can forward from one queue to another?
I believe so, but I think it depends what you mean by conditional. So I think there are some conditions that you can set, but I would have to go away and find out how complex you can get with that.
I'm thinking if we have, for example, let's say 3 queues, and based on the messages I'm receiving, I want to send, for example, message 1 to Q2 and message 2 to Q3, for example, based on certain conditions inside that message. I'm wondering if that condition can be created.
I believe so, but I'll go away and have a look at that because I'm not 100% sure.
No worries. Thanks, Paul.
I feel like that's a subject to my next blog post, actually, now you've said that. Okay. So that was sending the queue. What I'm going to do next, I'm going to create an auto delete queue. That's going to create me a new queue, which if I bring this up, I've now got this auto delete queue, and I'll send some messages to it just for the sake of sending messages to a queue. I think he sends about 100 messages to the queue. So in the situation, wow, that's slow. I think that might be my internet connection more than anything. That's horrendously slow. While we're waiting for that, I'll just go through the code, and then we'll do a big surprise when the auto delete queue gets deleted automatically. Cool. Okay, so the first thing I suppose is the create and delete the queues. Again, so at this point we're creating instead of the service bus client, we're creating an administration client, which is slightly different. Although it's still the same library. Creates the administration client, and then you get a whole new set of functions that you can use, or methods that you can use. So you can delete a queue, for example, give it a queue name. If you want to create a queue, same thing. So exactly the same sort of setup. Obviously, if you create a queue, you've got to tell it certain things about the queue. For example, what rights, your access rules and all that kind of business. But then you can set up things like this, where the forward's going and so on. The show connection details, and nothing really to write home about it. It sets up the administration client, gets the queue, and basically goes through all of the kind of authorization rules of it, which just tells you how to connect to it and so on. And then, so we've been through the send message, not much point in showing that again. The auto delete queue, again, same process, but this time I'm just passing an auto delete property and I'm telling it delete in 5 minutes. Yeah, that's probably all that's worth mentioning now. This is either going to have been 5. It's not even sent them. Oh no, it has. Yeah, it's sent them because I killed it. It's not been 5 minutes yet, so we'll either forget about that completely or I'll come back to it, see which one. Okay, so the next section is performance. So what I've come to a conclusion of is that there's essentially 2 ways that you can improve performance, or one way, and that is make less calls to the service bus. And there's effectively 2 ways of making less calls to the service bus. So what we've been doing so far is known as peak lock. So you take the message off the service bus, it's locked, and then you explicitly go back to the service bus and you say, I'd like to complete that message, please now. That means 2 calls instead of 1. So if you do what's called receive and delete, that will give you the message and go, right, it's gone off the service bus now, kind of happy days, which means 1 call, but obviously there's a price to pay for that, in that if you kind of drop that service bus message, then it's gone. So that's the first way. And the second way is that if you have more than 1 of these, to do them at the same time. one of the things I've put in is that if you kind of get to this point, you might not be using the right tool in Service Bus, because that there are other options that you can use that will give you higher throughput for, Service Bus isn't the right option for a massive amount of data streaming or whatever. And obviously be careful with some of these techniques, because you can end up creating yourself more problems than you're solving. Okay, so batch processing. So this allows multiple messages to be sent at the same time. You can use it for send and receive to an extent. For the send, I've not come across any downsides. So you can send messages in a batch, and it'll just send them all together. Batch receive has a problem, or a potential problem, with lock-in or lost messages. And for receipt, you might not get the number that you ask for. Okay, so why has batch and prefetch got a lock-in problem? So in a normal scenario, you would receive a message off a queue, and you'd lock it, as we said. So you essentially receive the message and you say, I'm going to lock that message until I'm finished with it, and then I'll tell you I'm finished with it. In a batch situation, that's a bit different, because you receive 100 messages off a queue and you go, I'm locking them all, and I'll tell you when I'm finished with them all. If those messages have a timeout or something like that, then they might time out while you're trying to process them. And the second possibility is lost messages. So you can do the exact same thing with receive and delete. You'll get one message. But to be fair, the same problem. This isn't exasperated as much as it is with peak lock. If you lose that message, so if that message goes, then it's gone. You'll never see it again. If one of these messages go, then that message is gone. You'll never see it again. So I suppose it's not so much exasperated as it would be with peak lock. You still got the same problem. It's just at higher scale. This is an interesting one. So when I first wrote this talk, and I did it for the 2017 version of the SDK, there's a function there to complete all of the messages that you receive. So if you do a peak lock and you download 100 messages, there's a function that basically says complete 100 messages. And what that did was, it behind the scenes had a for each statement that went through all of the 100 messages and then called complete on every one of them. Quite thankful that the new version doesn't do that, because it hides the fact that it's not really doing anything for you other than a for each statement. So possible use cases for the batch. You might want to replay a sequence of events, for example, what got held up. If you have a high throughput system, again, depending on how high event, Service Bus might not be the correct answer. And obviously the archetypal example with this is sending emails to everybody. Cool. Okay, prefetch, it's similar to batch receive. So basically this is a way of you reading your messages, but you essentially ask it to implicitly read ahead for you. So you'll say, I'm going to read the next message, but actually download the next 100 for me. But it has the same issues. All of the same problems that exist with batch exist with prefetch. Okay. Because of time constraints, I'll probably just do the first part of this batch demo. So start, we'll run this, and So what I'm going to do here, I'm going to send 1,000 messages. That takes a while to send, around about 30 seconds usually. Although given the speed that I've been getting, it might take a little bit longer than 30 seconds. The idea is that what I'm going to do when this is finished is I'm going to send the same 1,000 message batched and see the comparison between the two. Let's see. Oh, there we go. So it took about 32 seconds or thereabout. If I send them batched, it took under a second, like a long way under a second, just because it's one call instead of 1,000. So it's kind of obvious that it's going to be faster, I suppose. What we're going to do here now is a receipt. So I'm going to receive 100 messages here. That usually doesn't take too long, but it's receiving the 100 messages separately. And then, yeah, so that took about 10 seconds. And then I'm going to batch receive the 100 messages. Did I press? Yeah, so there's a slight increase in speed there, but it's not. You don't get the same improvement in speed on that. I'm going to skip the prefetch just because of time constraints. But if we have a look at the code, so I mean, I'm sending 100 messages. I don't really need to go into the sending 100 messages because it's no different than the send messages that we've done before. It's just in a loop. The send batch is a bit different. So what you've got here is send messages, plural, and you give it an array of messages. And the receive messages, again, the same thing. So instead of receive messages, and you can receive them in bulk. But as you can see, I'm basically completing them one at a time, which takes time. So receive and delete is obviously much faster. Okay, prefetch. So prefetch is just a configuration, whereas batch is kind of a method. If you use both together, it causes strange things to happen, so probably don't. Okay, so last couple of bits here. I've not got any more demos, you'll be pleased to hear. So Azure Functions, basically with Azure Functions, you can bind a function directly to a service bus, so you can process messages on a service bus. There's essentially two modes of Azure Function. You can have in process, which I think exists in .NET 6 but will not exist in .NET 7, and you can have out of process, which seems to be the way that things are going, and with good reason, because I've had plenty of problems with NuGet library held with the in process version. Azure Functions 4 supports .NET 6, and essentially that's how you pick up a message from the service bus. You just bind it to the service bus. An identity-based connection. So this the connection string that we've been using all the way through this is just a sort of string that you get off Azure. It obviously has a downside in that you end up, there's ways around it, but you can end up accidentally checking these things into source control. The advantage is that with this is that you just basically tell it, okay, I want you to base this on my identity, and you'll use like a service principal or whatever to authenticate. And then you don't need to store that kind of stuff in your code. So it's just all implicit. and you can, this is kind of the screen where you'll add your the permissions for your role assignment. Cool. Okay, so summary. We talked about dead letter processing, how we can deal with messages that hold up a queue. Talked about transactions, how you can have multiple operations at the same time and fail or succeed together. Talked about scheduled and deferred messages, where you can send a message in the future or receive a message and ask it to be essentially received in the future. Sessions, which was the sort of using a correlation ID but on speed. Service bus management, where you can create and destroy queues and topics and so on in code. Auto forward and auto delete, where we can basically have a message go from your queue to another queue, potentially based on rules. I'll get back to you on that, Mohammed. Auto delete, where you can effectively retire a queue if it's not being used. Prefetch and binding for performance, where you can batch things up and sort of process them in bulk. And then we spoke a little bit about functions and identity-based connections. Cool, thanks for listening. And there's some useful links.